Now let us start understanding our second data structure, which is called a linked list. Linked list is also another type of linear or kind of list-like data structure similar to an array. However, the way the data item stored in that list is very different compared to an array. In an array, all the data items are stored in contiguous memory location, one after another. However, in linked list, there is no such restriction, and the elements or the data items can be stored anywhere in the memory. Anywhere means the item which is identified as 0, that can be stored in the memory location, say 1000, or the next data item that is which is 9, that can be stored at a memory location, let's say 5679. I'm using some random numbers. And the next location over here, the next element over here, it can be stored in, let's say, some random memory location which is 2563, and the last element can be stored in 6700 or somewhere. So it doesn't need to be contiguous location like an array. Now, in order to facilitate that, whenever you will construct a linked list, you need to remember a few things. Whenever you will construct a linked list element, or sometimes we call them a node or a linked list vertex or whatever, in the figure it is shown as this entire rectangle, this rectangle, or this one, or here this one. So all these rectangles are either called element, node, or vertex. So whenever you want to uh, construct a linked list element or node or vertex, you must have two different parts in it. The first part is the data item. That data item can be an integer, or it can be a character, or it can be a floating point number, or any type of data item. Then there is a second part, which is this one, which contains the memory address or the memory location of the second element, or the next element or next node or next vertex. So that's an additional part which was not there in an array, but it is there in a linked list. Now, so what does that mean is linked list basically has each node in a linked list basically shares a previous next kind of relationship. For example, this node, the memory address is the first node basically contains the memory address of the next node. The This node again contains the memory address of its next node, which is identified with 2, and the content is 22. Then again, this node also has the memory address of its next node, something like this. And in this way, a linked list can grow. So since there is no restriction to maintain the contiguous memory location like an array, many operations become significantly more efficient in a linked list comparing to an array. For example, both this insert and deletion or removal of an element in a linked list is significantly more efficient compared to an array. Why? Because in an array, in order to maintain the contiguous memory location, you have to do a right shift when you want to insert an element, or you need to do a left shift of all the elements afterwards when you want to delete the element. But since The linked list do not have this contiguous memory restriction at all. You really do not need to do any type of right shift or left shift during insert and delete operation. And that is why the linked list for these two operations works significantly better or significantly more efficiently compared to an array.